Let me introduce the next speaker. He's already standing there and ready to give a talk. So Professor Raymond, also a friend, a long-term friend of NUS, IBM. Raymond is a Canada Research Chair of Data Science and Analytics. Comes from University of British Columbia, very far away Canada. He's also the founding director of the Data Science Institute, our sister institute in Canada, at the University of UBC. So he's an elected fellow of Royal Society of Canada. Yeah, but I think it's quite interesting. He was named as one of the world's top 75 academic data science leaders 2022 by the Chief Data Officer magazine, which is out of the MIT School of Management. But more importantly, Raymond's research area has been contributing for the past 3 decades in data mining with a specific focus on health, informatics, and text mining. He has published over 220, more than that, huh? 220. Keep it up, okay, the competition. Peer review publication, and so on and so forth. So yes, we are very happy to have Raymond here today to also talk about a little bit more on natural language processing and healthcare applications. Yeah, and yeah.
Thank you. So thank you for inviting me. I have given a few talks at NUS, over the years, the Department of Computer Science, the medical school, and this is the first time that I give a talk to this audience from the IDS. So now, there are good things and bad things. I mean, not bad things, but there are pros and cons for me to follow Ben. The good things to follow Ben is that he had given such a good introduction about large language models that I think I could maybe skip one slide in my talk. But the con side of following Ben, and I want to kind of realign your thinking about my talk. So my talk is not about ChatGPT, and in fact, my talk only a little bit about large language models. So my talk is a lot more general about natural language processing, and I hope. I know that there's a good component, of you that also do NLP, and I'm sure you'll agree with me that ChatGPT is not exactly NLP, either. And so I'm actually focusing more on the more general NLP side. And in fact, the most important difference between my talk and Ben's talk is that I'm going to take a very deep dive into a very important application domain, namely healthcare. And Skong, talks about the vision of IDS. And the last few words, he was talking about real life challenging, problems. And so there's not too many real life challenging, problems than, life and death and human suffering because of illness. We went through 3.5 years of COVID. We know what health means. We know what public health means. And so in a way, I think, the healthcare domain is a very important area, not just for ourselves, but definitely, for the society, as a whole. So that's the nature of my talk, that I'm going to focus on healthcare. So I'm going to come to this question, and I'm going to say that I'm going to answer. I need a point. No, you need to press down going forward. Yes. So I'm going to. I have 2 slides where I try to answer the rhetorical question of why NLP for healthcare, and this is the first answer. And then in a few slides later, I'm going to give you the second answer: why NLP for healthcare. So the first answer is that in the medical domain, unstructured documents is a gold mine when it comes to information about the patients. And there's a lot of what we call official documents, And they might be like medical reports, clinical documents of various types. Then there's also what we call user-generated content, blogs, text messages, social media, on one of his slides. So I will also talk about how in the clinical space it's very important not only to focus on clinical documents, official documents, but also user-generated content. So that will be in the second half of my talk. Now, machine learning, given its buzz and its advances, have been applied to healthcare for more than 10 years and maybe even 20 years. But for the most part, it has been applied to more the structural part of it, electronic health records being the primary example. So if there's one take-home message that I want to remember for my talk today, is to tell you the really huge opportunity for you to use NLP and apply it for better patient care. And so you could use that as an application domain, for your research, for your startup activities and whatnot. But it really is a very important and very fruitful, domain for us to deploy the tools. So let me give you a very specific example why this is such an important problem. And cancer care. And I don't know how many of you in your lives have experienced your friends or your family members going through cancer. And I hope not, but but life is life. Sometimes it is not possible to avoid that. Now, and so I'm going to describe, 3 phases of cancer care. When someone, has some symptoms, and they will go through a diagnosis phase. In this diagnosis phase, there's all kinds of reports that got generated: X-rays, CT, biopsies, and surgery. Every single procedure generate a report. And so there's a lot of information being created by experts in the reports. Now, suppose that after that diagnosis phase, someone unfortunately is confirmed to have cancer, then they go through a treatment phase. And in the treatment phase, there's rounds and rounds of chemotherapy. There may be rounds and rounds of radiation. There might be surgery, and so. And again, every single step, there are documents. Now, let's just say that it works very well, for the treatment, but that's not the end of it, because there is another phase, which is post-remission phase. There's, routine checkup. There's, 1 year, 5 years, up to 5 years, but there will be other procedures. And suppose someone is unfortunately going through a relapse, and it happens, quite a bit for cancer. I mean, obviously it depends on the types of cancer. So if someone has a relapse, it goes right back to the beginning: diagnosis, treatment, post-remission. So my point is that in this whole process, if you take cancer care as an example, every step will generate so much useful data embedded in documents that are unstructured, and we have a difficult time actually using it in the healthcare domain, making decisions. So the current practice is that all these documents are very siloed, and oftentimes the documents are used very locally. Every single step, a clinician will be reading from the previous step and made a decision. And so the time frame of what they're looking at is typically very short, a few months and so on. But as I described in the previous slide, the whole journey of the cancer patient is like 15 years and even longer. So there's really no way there is really not a very good organization in our healthcare system that we collect all these documents and holistically build a picture of what we have known for this patient for 15 years, for 20 years, based on unstructured documents. Now, even if we have done that, the other problem is that right now in the healthcare domain, for the most part, a lot of these documents are interpreted and read by humans. And I mean, which is a good thing, but as we all know, particularly with aging in our society, the demand for for such interpretation is very high. So it introduced a lot of delay. And so the idea is that, well, this is exactly something that maybe we should automate. We should try to automate, even if the automation is not as accurate as a human, but imagine that it's much faster. In the cancer care that we now have, a lot of these documents sit in the BC cancer care for 6 months. And to process a document like this is probably like takes 6 seconds. So for cancer, 6 months is a huge amount of time, right? Cancer, some of the acute cancer, you literally could go, someone could go to stage 2 to stage 4, within a year. So if you lose 6 months waiting for a human trying to read the document for you, or maybe read the past 5 documents, a lot of times you'll be lost. And so the idea is that why don't we not use an algorithm to help with that process? So we have a program with the Ministry of Health in BC, where we try to do a lot of extraction. So Ben talked a little bit about relation extraction, and our work is a little bit simpler here because we're not thinking about general open relation. There's specific, what the clinicians say, fields of interest. There's all these reports, they have 150 fields of interest that they want to extract from the document. And once they've extracted it, then they could use it for improving detection of reportable cancer, understanding what is the diagnosis, should someone be fast-tracked because of the severity, and then at the end we even talk about relapse. So that is the idea of our program. Now let me give you a specific example, just so that I introduce the concept of fields of interest. This is a breast cancer surgical report. This is a real surgical report, and the report talks about all kinds of things. Some of the fields of interest that the clinician wants to know is, okay, do we find cancer? Where? How large? What is the stage? So I mark some of this, box. Okay, there's invasive ductal carcinoma, so there's any cancer, and about 1/2 of the specimen. So it is quite serious. This is a severity score. It's called the Nottingham score. The Nottingham score is 8 out of 9. It's grade 3. And how large? 2 millimeters. And then I also want to highlight the fact that this is not a search. So they cannot just use a search engine to search a report, because then when a surgeon was writing this report, the surgeon is writing it in English. And so the information that they're looking for could be anywhere in the document. So typically a report would be like a 2-page document. So anywhere in this 2-page, the clinician will be describing, what they have seen, or the surgeon would be describing what they have seen, and then they write the report. And so, but then it's not only a search, because there might also be a negation. One of the important things when it comes to cancer is this idea that's called lymphovascular invasion, which is like how the cancer cell has already, invade. And so for this patient, is not entirely bad news, because it said there's no lymphovascular invasion. Now, negation, this is a simple negation where the negation no is immediately in front of the term lymphovascular invasion. So that is easy. But when humans write things, sometimes the negation comes like a few sentences later, or maybe the next paragraph. This is where it actually motivates the idea of transformer, because it's not necessarily local, where you could find negations and modification in language. So this is why this is a very specific example of how it could be. So what we try to do is in fact use an NLP, power, detector, extract the field of interest, and in fact, what we do is simply take the data from the unstructured domain and move it to the structured domain. And then they know what to do. Because now, as long as we put it into the structured world, relational database, or even in an Excel, they know how to take over. What they need help is to get the data in unstructured document and extract them to the structured world. And so this is really, I'm just showing that this is some of the 40 or so of the fields of interest, and out of 150 that they want. And I just want to show you that there's a very big diversity of what is called the fields of interest. So this actually ends the first 1/3 of my talk. Is there any question or comment before I turn to the part that I think connect a lot more with Ben? No? Okay. But feel free to go. So as I mentioned to you, I'm going to answer the question of why NLP for healthcare twice. Now this is the second time. My first answer was the unstructured documents in the healthcare world is a gold mine of information for patients, but we don't use it. The second answer is that, well, this is very timely because Ben has built a foundation, in his talk in the past hour on why NLP, and to some extent fueled by advances in machine learning, this large language models, pre-trained language model has really been very, very impressive. Not just in a general sense. I'm also glad that he was showing BioBird because we actually use BioBird a lot. And we don't use ChatGPT, but we are using BioBird. But and this is a simple introduction of what BIRD does. And I just want to actually say that natural language processing is the name of the field. But we actually prefer it to be a little bit more nuanced because what we are trying to do is, processing, spell check, it's also, processing. You are changing the word, you're correcting, spell. That is NLP in a simplest form. But what we're trying to do is really to teach natural language understanding. And the word understanding is a lot harder. And I think Ben also was talking about, maybe Ben or Seacom was actually talking about how language is, is related to humanity. You are going to hear that in the second part of my talk. Language to us is a window to what the person is thinking and what the person wants to say, what the person feels, or what the person is not able to feel, or what the person is not able to feel. And so that's why to us, language is a very important, lack of a better term, in the medical field, it's called biomarker. To us, it's a huge series of biomarkers that we could sense. We're doing sensing of the person based on what is in their head. And so that is why we want to understand. So this, I'm saying this is because I'm trying to introduce how the understanding word relates to what we are going to see in the second half of this talk. So, Bert, I think I could skip some of this. I got this from a friend, and this is a very interesting evolutionary tree. It describes how the language models, how they are descendant of each other. So you can see that Bird is really early. Bird is really early on this branch, and then there are cousins like Roberta and well, actually Bird is here. and then there's Ernie, and then there's a new branch. You see GPT-1, GPT-2, GPT-3, and then ChatGPT. And the interesting thing about, so Ben also mentioned about open source and closed source. If it is unfilled in a box, these are all closed source, and whereas the earlier ones are all open source. What is really amazing, and I think what is really amazing to point out is just look at the y-axis. This is 2019, and this is 2023. This is 4 years. So it really is amazing how this language model business have exploded. And but I thought this is a interesting picture that I got from a friend, and I mean I'm not smart enough to generate this truth. So I think I could skip this. It was just a very quick introduction of what we could use a large language model is. Basically, we use it to do question and answering. We use it to use what's called NLI, natural language inference, for us to do the extraction of the fields of interest. So for those of you who are a little bit more technical, I connect that to you. Now I'm going to change a little bit now because I want to talk about user-generated content, and it's really very important, not intellectually, but it's even in the healthcare world. And it is not something that actually has been widely used in healthcare because we don't know how to do it. So clinical documents are written by well-trained experts, radiologists, pathologists, surgeons, nurses, very well-trained. But why are we only sense? So we're talking about sensing. We obviously rely on the opinions of professionals. But at the same time, why are we ignoring what the patients have to say, what the families have to say, what the caregivers have to say? What do they prefer? What is their experience? What is their mood? What is their sentiment? And what are their needs? And so now UGC, user-generated content, from NLP perspective, is actually harder than a lot of the clinical documents, because people who are writing, patients and the families, they are writing, they're very diverse background, very different styles. They may not even be grammatical, very different length, and very, very subjective. And subjective is not necessarily a bad thing. Subjective could carry very important information, right? If someone say, I'm in pain, and I think this really sucks, that emotion is informative. So there's a very different genres from a natural language processing point of view too. And so the demand to do the right extraction, to do the right analysis is a little bit different when it comes to clinical documents. So this is why I'm very glad that the social media on the, are very prominent in the word cloud. So listening to the patient. So we have 4 general tasks that is important. And I think when it comes to listening to the patient, first of all, what are the patients talking about? Are they talking about the diet, talking about the treatment, talking about the doctors, talking about the nurses, talking about the food in the hospital? So what are they talking about? And so that in natural language processing, for those of you who are familiar with the field, that would be roughly like topic modeling. And then there's the area that's called needs detection. What do the patients need? What do the family needs? Do they need support? Do they need health information? I'll give you an example later on the needs detection. And then what is called dialogue ads. Why are they talking about certain topics? Do they want to have information about certain things? Do they want to ask questions about, I have a skin rash after I take this drug? Is it a reaction? And so we want to understand why they are talking about certain things. And then this cost analysis. This is a very interesting aspect, particularly when it comes to neurology. This is about whether the brain. So we are trying to say, we're trying to analyze the text and see whether the patient is even coherent. Does this look like something written by a person who is sane? Or maybe this person is insane. Maybe this person is getting insane. And this is exactly an illustration of what I said earlier, that how we use language as a sensor to what is in the brain, what is happening to this patient. And so this is, so I'm going to illustrate, we have done work on all the, all the 4 tasks when it comes to patients and, patients' conversations, but I'm just going to focus on needs detection. And I'll just show you a few slides where we're using the American Cancer Society online discussion forum data, and the task is just to detect the needs. And I'll give you a very 2 quick example. This is based on, typically, so this is actually based on this data set that is about 52,000 posts. And between 2006 and 2016, now the forum exists as we expect. There's Reddit posts and all of them. But in the healthcare system, very few systems would have the resources to go and try to understand every single post, try to extract the information from every single post. So it's very labor intensive and it's very time consuming. And again, this is the kind of thing that an algorithm could actually be very useful to try to analyze, all these posts and maybe be able to, create an early intervention system, highlight certain posts as to maybe having a follow-up, to be able to build features like. So let me give you 2 examples. This is from the ovarian cancer online discussion forum. The first on the left-hand side is a post by someone, and it says, I finished 6 rounds of carbotaxol and I'm slowly recovering from the assault of the treatment. Has anyone experienced joint pain after treatment? I've noticed increasing pain in both hips and recently, knee pain. The sentence in red is not in the data. We color code that as red because this is like the attention mechanism. We identify that because of that red sentence, we classify this post as someone seeking, there's a physical need. This is a question about a physical need. Now contrast that to the next post. Someone said, I have 6 to 8 months of chemo. I'm so scared. I do not know what to expect. I'm having a hard time dealing with this and attending a support meeting. I have a difficult time staying positive and so on. And so because of this red text, the algorithm is classifying that as an emotional need. Someone needs some emotional support. And so this is 2 examples where we are using NLP. This was a paper that we published 4 years ago, and it is basically trying to do what we call need detection. The last thing that I want to point out is that at least for that data set, the cross-validation accuracy is actually quite decent. So it is possible that we could do work like this and be able to really understand what the patients are saying and maybe identify individual ones that we want to provide some more help. And I'm coming to the last part of my talk, and I really want to talk about psychiatry, because psychiatry is interesting that not only are the user-generated content unstructured, even the clinical documents are often unstructured because psychiatric assessment doesn't have what, in the healthcare system, they will call a case report form. So it's not a standard form that you fill out, okay, what is your blood pressure, what's your temperature. And so that part is, very structured. In psychiatric assessment, it's basically the psychiatrist writing a report, 2 pages, 5 pages, and it's unstructured. The clinical document is already text. And then on top of that, you have social media posts. And I just want to put it here that I think social media is particularly important for the younger generation, for Gen X or Gen Z, because they actually use, so in essence, estimated that 85% of all youth are heavy users of social media. What they say in social media is important. I mean, now, even for forensic purposes, we will now go, the police will actually go back to the to the social media posts after someone has committed a crime. But imagine that some of these tools will actually help us to do early intervention. But again, it's very time consuming. But again, this is exactly the kind of thing where an automated algorithm would be very useful. So we have one specific project where we have 1,000 youth for this hospital. So for those of you who have been to Vancouver, there is a hospital called the BC Children's Hospital. And the BC Children's Hospital actually have a psychiatric branch. And so in this data set, we have 1,000 youths who have been admitted through this emergency room, for psychiatric emergency room, and due to self-harm. So they're not necessarily trying to kill themselves, but maybe they cut themselves and do all kinds of things to harm themselves. And the data that we have is the admission notes, and then they stay hospitalized, so there's a discharge summary. And for this particular project, we actually have permission to get the social media posts of the youth 6 months prior to admission. And the idea is that we want to try to build a model to do a risk stratification, which is to say, how likely is someone coming back in 2 months? And the data is all unstructured from the admission notes, discharge summaries, and of course the social media. And so we believe that there's actually a lot of very useful, very useful data for us to build a predictive model so that we could get more help to those who we think is more likely or higher risk to recommit the self-harm to themselves. So that's it. And I think this is maybe my last, it's not, the last part of a little bit of the technical work. So, psychiatry is not just about, people who have committed self-harm. In general, the whole idea of, mental wellness. And so we want to go a little bit further upstream too. We don't want to be just tackling, people that are further downstream that are a lot more serious. And so we have been working. So there's a Health Canada funded project to monitor the mental health of university students across Canada. So there's UBC, University of Toronto. There's about 35,000 students who have actually signed up, and across Canada. And the reason why this project got funded was obviously motivated by the pandemic, and because Health Canada want to understand how the pandemic or the shutdown, and I'm sure all of you understand, and we understand too as professor how the pandemic has really changed how we come to the university, how we learn. And so this particular project is one one way of monitoring some of that within Canada. One piece of it is to actually the user-generated content. So we want to understand. We want to understand a few questions. What do students talk about? Now, so this is like topic modeling. Many of what they talk about may be okay, may not be a concern. But specifically, there are things that really stress. But specifically, we want to understand what we call the stresses. What is stressing our student? And are those stress getting worse? Are those stress getting better? And then there's also the regional, difference. Is it different across campus? Are the stresses at NUS different from the stresses at NTU, for example? So in this particular case, we want to be able to understand that. And so we have been building a platform that allow us to do this analysis. So this is a very simple diagram. You have Reddit posts, for example, we go through a language model and hence topic modeling. So this is why it's related to language model. We do a bird topic modeling. We find out different topics. We find out what the representative sentences are. And the interesting part about this platform is that, so this is where the word link comes in. There are specific psychiatric documents that we use. So we want to use those documents to kind of define what the psychiatrist may be interested in understanding who they want to identify. And so then you have the psychiatric document, you have the sentences, and then we are going to flag certain sentences as closer to what the psychiatrists are most interested in. And then we try to identify what the stressful sentences. Are people worrying about tuition? Are people worrying about housing? Are people worrying about jobs? Are people worrying about in the case of the pandemic, are people really worried about failing the exam and how they're going to catch up and things like that. So we have been building this platform, and the idea is that this is in the earlier slide. This is really a framework that allows a psychiatric analyst to do that online, so that they could actually look at the Reddit post themselves. So this is really a online platform. So I think I have outlined for you how NLP could be very important in extracting from clinical document, analyzing user-generated content, from cancer to chronic disease management, and then lastly in psychiatry. And my last slide is that I have two final comments. And I think Ben already helped me with one, which is the multilingual aspect. The multilingual aspect is important within Canada because Canada has two official languages, French and English. English, as we all know, the large language models are all based on American English. Actually, it's not even English. It's not Singlish for sure. And but French and but what about Chinese? What about Japanese? What about Italian? German, and the multilingual aspect, particularly in user-generated content, is important. And I think the large language models, so Ben already talked about ChatGPT, is actually one of the ways that might be useful in actually tackling some of this multilingual aspect. So from text, and I just want to say that even though I've been talking about NLP, and we were talking about written text, I actually want to say that speech is important. So when I talk about NLP, I even broadly think about speech. in psychiatry, there's a lot of tapes. I mean, people don't type, they talk, and then they just, tape it. They just record it. And so one way of reaching to that data is, well, you just transcribe it. So you transcribe it into written text, and then you apply all the machinery that we have talked about on the written text. But then there's also, you could also do signal processing to extract very important acoustic features. One of the most important features when it comes to some of this is silence. How long does it take someone to respond to a question? Right? I joke about, the fact that in a lecture, you'll say, okay, can anybody answer this question? Silence. Silence is a very informative feature. Or someone get angry, right? In a speech, or someone starting to talk louder and louder, or someone starting to talk softer and softer. All these are very important features. So we could extract all that data, including the NLP, but also have the acoustic, features, and then you could build models about them. And this is not just about psychiatry. In general, the society has been using, I don't know how many of you in the past few years have relied more on, Siri and Alexa. There really is a lot of data. I have, after I gave some of these talks, I have actually someone from the Autistic Society who actually came out because they were very interested in having the conversation between kids when they grow up playing at home, because this is the safest environment that they have. And they actually want those recordings to be analyzed, and they try to build an early detection of autistic, child. I have another person who actually think about using speech, and they were talking about postpartum, depression, right? So, mother has just given, birth, and many of the mothers actually suffer from depression. And the idea is that if you actually have some of the home tapes about how the mom interact with the baby, so this is not about the baby, this is about the mom, then you might be able to build a model that much earlier detecting that a mother might be undergoing depression. And so again, those data is there. And the fact is that how do we take advantage of that so that we could build very useful, application to fulfill the vision of, real life challenges. So thank you very much. I think explain a little bit about what happened.
Well, I don't need this. So for giving a very good talk on the real life implication of our work from the technology that Ben has also introduced. In fact, you can see, I think we talked about data, so it's not just text, there's also speech, and actually there's also images.
In medical imaging is a big,
So all these all of them are is an interesting aspect. So data is everything, and data is also multimodal. So any questions for Professor Raymond? Silence. Okay.
I lost it.
Exactly. And then one of that may want to do long data in this room. But when it comes to management report, I think one of the pilot they always communicate in language in whatever. If you could design going forward at least where doctors, are trying specifically having a team level of data science, super question. How would you do? I appreciate it. Like the main protocol, you can just go and doing that. How would you do it? And do you think is it actually desirable? Is it actually desirable to do so, or do you think medical reports will be international language somehow convey some kind of NLP grasp there, sort of sort of provide.
Yeah, so that's a fantastic question. Actually, that kind of framework already exists in the Canadian healthcare system. The problem is that only 60% of the pathologies use that time.
Is that the older generations first one to use it, or the because you know they say something new medical field along. Medical field is there, the things they apply once the new generation learn in medical school, gets the position and the older generation retire.
I was told that the sociology did not say, you know, there are people who use a lot of people use hate. This is one type of
Okay.
but then I think there's another very important aspect. You know, even if you have everybody the open-ended text box when you read it, it's the most important, right? Because so I mean, imagine the pathologist goes through a certain set of questions, and all of a sudden the pathologist writes 5 lines something.
Yeah.
About that, you better read it. Because there's a reason why they say it. And so I think even though we don't have exactly that, that's specifically for the yes. You still need to handle that's the voice, you know, that is the goal. Yeah, so I think it's been
the question was more around the practical aspect of when you really analyze this clinical report for the results of pathology control, what you really realize is you end up getting roughly 5 words from them or 6 words. Like they're writing actually 5 lines is very rare. Like so, it's pretty rare. And even in their 5 words, these are technically most of the time acronyms that they end up writing, which again, even if you go and take bio, if you take even domain-specific language models, they actually don't have them because those domain-specific language models are trained on papers rather than the reports. So how you think?
well, so I showed you the example of lethal vascular invasion. It is a concept and it's very important to all kinds of things. What biotech won't do. So we do, I mean, we do find it works like that. And then in the future, we have to believe that once we are what we're doing, in British Columbia is big enough as a government that I think we are going to lay out this based on the cancer document or based on clinical documents. So I mean, then talk about BioBird. So BioBird has bird, and then with a lot of PubMed publications. There's a clinical bird, which actually where they actually has a clinical document. But these are generic clinical documents. I think in a few years' time, we will be able to try to convince the government to look, spend some money do your own cancer bird, do the British Columbia cancer bird. And so that people actually be exactly tackling problems. I think we were doing a kind of like a free shot learning fine tuning. I think eventually we really are going to use it a big time to have exactly as some of them.
The first one, I to ask whether you think it is applicable to use things like BioBird or user generated content, because you know that the input data and chemical spaces like the presentation is very different. So those presentations itself and the user speaking a big things like expected communication as well. So do you think that BioBird is kind of clinical this like on the user generated content that
So so for the first question, so the previous question was just talking about very specific medical things. And we talked about how the Bible may not put enough for that because it's a very specific window at the medical community. And now the first part of the question about user-generated content. I think Bible is actually good at it because typical patients and their family don't use the medical term, they use general term. And so in that sense, the more generic, I won't necessarily say the vanilla, but the more generic the language model might actually be sufficient. And I'll give you one specific example. One component of analyzing user-generated content is for sentiment analysis. And so there has been a lot of work trying to use sentiment analysis itself, as many of you know, predated the large language model. But in recent years, there's a lot of sentiment analysis frameworks that have been now enhanced with the language models, and I think they've been quite successful. So I think for the more general content, we have to use for analyzing user-generated content. Maybe we don't need as much fine tuning as, in fact, the more technical clinical documents. Second half of your question about how we want to deal with multimodal data. So you are using speech and you are talking about user-generated content, but I would take we could be even more general. What about imaging data if you want to build a model? And I think if you are a neural network person, you will say, oh, we'll just put it in a neural network, put it in a deep network, and let it deal with it. But if you are more classical, you're a machine learning person, you'll say, well, I'm going to extract certain features from the tapes, and then I just take the feature set from multiple sources for data, and then I could build a model, I could build a decision tree, I could build a support method. And so that's the more classical view. Then you could say that, well, in a lot more classical statistics, you could do ensemble. And you could say that, well, what does the UGC data tell me about this patient? What does the audio, data, tell me about this patient? And then maybe you want to combine the probability, whether someone is. So I think there's more standard ways of trying to deal with the multimodality of content. But I think the important part of my talk is to say that once you cross to the structured world, we have a lot more tools that have a lot more experience. What the world needs us to do is to cross from the unstructured world to the structured world. So we are just talking about how we could cross and extract from seeds, extract from images, extract from text, and once you relate them to the structured world, and then we're better. So I hope that answers it.
Okay. Thanks a lot for all the questions. So I kind of want to say at the end, I said earlier, language is the pathway to humanity. So a lot of this data is about what humans are thinking, what humans are feeling, what humans understand, and all this. So so I guess now that we're breakthrough with language, I think it really opens up the pathway for us to understand all this other data. Okay. So since I'm the host, I get to say the last word. All right. Yes. Okay. Thank you very much. So can I? We move on to the last part of this seminar. Can I invite Raymond and also Winnie to be on stage? We want to announce something that we are working on together. So can I have the next slide, please?
Yeah.
So this is we talked about moving towards the international stage, right? So we are about 7 years old now, so we want to move towards the international stage. So we have this, we are very happy to announce this so-called initiative that we have actually been discussing with Raymond for many years. So glad to see that it comes to fruition and glad to see that you are here to see to kind of officiate this initiative. So it's about establishing an international profile and certificate network in data science in a global setting. So what is this about? Maybe I'll ask both of you to kind of press some thing here. Okay.
Press something here.
Yeah, okay, all right. Yeah, okay. Yeah, okay. Please, so
I think we need music.
yeah, so actually, you want music, I want PhD student doing a music generation. So this is our new program, a postdoctoral exchange program with UBC. Can I go to the next slide? So we have talked about it. We have secure funding on both sides. For those of you who want to join us as postdoc, now you have the opportunity to also continue your postdoctoral training with Raymond at UBC site and also vice versa. We're also looking at PhD exchange. So I think it's very important for all our postdocs and students to have international exposure. We want interdisciplinary exposure and now also international exposure. So would any of you want to say anything? Maybe Raymond, you want to say anything to sorry, put you on the spot. Yeah.
Well, I mean, we think that the motivation, the key motivation of this program is that I think when we look at, I don't know about NUS, but UBC actually has been doing a very poor job when it comes to mentoring or enriching the experience of our postdocs. And the postdocs are the most highly skilled research staff that we have in our ecosystem. So the motivation of this is to be able to let the postdoc enrich the experience by not just working in one location, but working in 2 locations, 2 systems, 2 projects, and 2 beautiful cities. And we hope that, I mean, this is not a program for everybody, but for the ones who really want to try that, I think it will be very attractive for UBC postdocs to come to Singapore for 1 year and vice versa for Singapore postdocs to go to UBC and work for 1 year. And even though CCON, mentioned my name, this particular program is not mine. The whole Data Science Institute at UBC has about 30 faculty or so. It's very interdisciplinary. You have people in not only in computer science, in math and statistics, but also in medicine, in arts, all kinds of areas. So we really want people to be able to apply to this program so that they could try to find a suitable supervisor for what they want to do. So yeah. Thank you.
Yeah, so we are starting with the postdoc exchange. We are also looking at the PhD student including, not just with UBC, but also with Germany soon. So it's an exciting time forward.
Yeah, and all this in time for the pandemic. That's all personal. All right, but it's really good, going to be a great period for all of you. I think please tell your friends, tell everybody. All right, thank you. Thanks, Ginny, and thanks, Raymond. So let me introduce the next. Basically, please go and take a look at our. In fact, they've been waiting for a long time. Our postdocs, our students. Out there, you see all the exhibition. We really want to tell you right outside here is our PhD program. Actually, IDS has a very interesting PhD program. It's interdisciplinary. Our students can be from computer science, can be from business school, engineering, even health. In fact, we also have a faculty that's for multiple disciplinary. So please take a look at some of their work. They have been waiting for you for a long time. So they're become closer. Like I said, there's one that's on music. It's quite interdisciplinary. You can take a look at that. And then the other side is right across our PhD is our healthcare flagship program. So you see some of the projects that we are working on. Please again interact with the people there. And finally, on near the food slide, but please talk to all these people before you get to the food, but it's okay, you can go and get the food. The purpose is we put all the food all the way at the end so that you have to walk through. So we showcase a few of our cluster of excellence. So one on social media. So we in fact quite a bit of that is more on misinformation, which is very important, especially now with ChatGPT and all this, getting very good at faking humans, right? So then of course the NLP people are looking at various techniques, federated learning and smart city groups. Okay. So with that, thank you for sitting in for so long. Again, please give us feedback. Hopefully we'll do this again. And then we'll grow together, and we have interesting program to let you know maybe next time. All right. Please, thank you again. Please go and take a look at our posters and demos. Thank you.
Right? Oh, I should have thought that. Hold on. Oh.